Hello everyone, this is another nuclear reactor simulator video. This one is a quite simple one. It fits the category which I call the 3-notch reactor simulator. And actually you just act on 3 parameters to control the nuclear reaction. If you are used to RBMK 1000, VVER 1000 or BWR from Acme nuclear reactor simulators, this will be a piece of cake for you. But if you are not into nuclear reactor simulators, maybe this is a good entry point to understand the basic functioning of a nuclear power plant. Don't expect me to talk about xenon poisoning or things like that in this simulator. So let's start. This is online, so you just go to this website. I will put the link below in the description, and I will maximize now the page so it fits better the screen. And once we start the simulation, we just need to act on these 3 sliders here. One is the reactor core, the other one the primary coolant, and the second one is the secondary coolant. The purpose is to run a thermodynamic system in which the heat is generated here, which is the reactor core, and it goes all the way through the cooling tower here. By doing so, in the turbine, we can generate some mechanical work that spins a generator that produces electricity. This simulator is more complete compared to the other ones I mentioned in terms of budget and money side. So here we see the net profit loss according to the electricity we produce, and we will see this city that lights up as we produce more and more electric power. So let's start. I will click the reset button because now we are in very negative profit because I was just talking. So the profit goes at 0, and you see as I talk it goes negative because even if it's not doing anything, we need to pay like rent and things like that. So first of all, to start raising the nuclear reactor control rods, which is this slider here, we need some primary coolant flowing. So we'll start the primary pump. We click primary pump, and once it's on, we can start increasing the flow. Once there is some flow, we can start withdrawing control rods in the reactor, and we see how the reactor temperature increases. We should always be below 750 degrees. So the function of the primary coolant is to extract heat from the reactor, as the heat is created in the chain reaction. And then we see that the heat is transported into the heat exchanger. Once we reach I think it's 200 degrees, we can already start the secondary coolant. So we start the secondary pump and we increase the secondary coolant flow. And we see how this takes heat from the heat exchanger to the steam turbine, and we are already generating alternate current power. We see that the temperature in the reactor is increasing a lot, so let's increase primary coolant. And now we see how the reactor temperature decreases. So the flow chart is, if you follow my mouse, reactor core, primary loop, heat exchanger, steam turbine, cooling tower. You can never surpass the temperature in any of the stages. If you do, you will start damaging it and you will need to replace here. You see here repair facility and you need to pay money for that. So you need to increase power progressively so you don't reach the yellow or red part in any of the steps. So now I will keep withdrawing control rods, so I increase temperature in the reactor, and at the same time increase a bit primary coolant and secondary coolant. So the effect of increasing reactor core, which means withdrawing control rods, is to increase reactor temperature. The effect of increasing primary coolant is to decrease reactor temperature and increase heat exchanger temperature. The effect of increasing secondary coolant is to decrease heat exchanger temperature and increase steam turbine. This is RPMs, so it's the speed of the steam turbine, and also temperature of the cooling tower. So let's keep increasing power in the reactor. A bit more. a bit more primary coolant, and we see heat exchanger is very hot now, so let's increase secondary coolant. And you see the generated power increase more and more. Reactor is almost at the maximum temperature, so let's increase primary coolant and secondary coolant. At the beginning we can be quite brutal with the increases, but as we approach the yellow part we should be more and more careful. So let's increase secondary coolant to decrease a bit the heat exchanger temperature. Here there is the message. The secondary coolant can only be turned on after the heat exchanger is above 220 degrees. Okay, that's good. We can increase a bit more reactor power. And the turbine is at more than 2000 RPMs. We see the city, how it lights up. It's almost all light up. And the reactor core is at 720 degrees. Let's increase primary coolant. It's a bit hot. And now we see most of the indicators are at their optimum. So at the end of the green range, without incurring yellow range in which you can start damaging your material. I will increase a bit secondary coolant to see if I can increase a bit the power in the turbine. And you see how your net profit loss, it's negative, but decreasing the negative value. So if we continue like that, we will go positive and start earning money. For the moment, we don't need to repair anything. You see that the state of everything, AC generator, steam turbine, cooling tower, emergency venting, heat exchanger, secondary coolant pump, reactor core, primary coolant pump, and fuel rod life. It's all at 100% except the fuel rod life, which is because we're consuming fissionable material. At some point when the fuel rod life gets too low, we need to refuel the reactor. Okay, not yet in green numbers in our budget, but we are close. Let's increase a bit reactor power. As the fuel burn up increases, the reactor reactivity decreases, so we need to keep withdrawing rods to keep the power. And we went to green numbers in the net profit indicator. We have a warning in the heat exchanger, and we see how heat exchanger value decreases. It's being damaged. So we can increase secondary coolant to cool the heat exchanger a bit. I will decrease reactor power. That's not good. I have 3 yellow lights. Heat exchanger is going very low. Now they are green, but I need to reduce secondary coolant. So what I did by increasing secondary coolant is to move the extra heat from the heat exchanger to the secondary system. That's why now the AC generator and steam turbine are in yellow. And now it went green and everything is green again. Now the heat exchanger is in yellow. It means it may need replacement soon. I will decrease primary coolant. So all the time you need to make fine adjustments to be the highest possible in the green line before incurring the yellow part. Heat exchanger, let's see how much is it to replace it. So it's $750,000 the maintenance and repairs in the heat exchanger, and we don't yet have $500,000, so we cannot repair it. Now everything is good. We're generating 97 megawatts. The city is almost all light up and we are making net profit. So let's wait a bit to see if we can reach $750,000 net profit and we can repair the heat exchanger. If you have a failure, it means some of the elements go below 50% and you don't have enough money to repair it. It's the end of the game because you cannot repair it, and with a failure you are not producing any electricity or any net profit. So now it's a bit critical with this at 65% and not yet having $750,000. Now it's good, we could already repair it, but I will just wait because it could be that we need to repair something else first. So I will increase a bit secondary flow to decrease heat exchanger temperature, but we are a bit in the limit in the AC generator also. Okay, that's fine. And we have almost 1 million, or a first million. We also get here some game score, 2,500. I don't know really how this is computed, but I guess you can compare your performance with your friends with this score. Demand is satisfied in 88%. We can increase a bit secondary flow and also primary. No, let's decrease because the primary column pump is almost at the yellow part. So I will increase slightly reactor power and decrease primary coolant pump. Okay. We have 1.25 million. Maybe when I add 1.5 million, I will repair the heat exchanger. And I will still have $750,000 left. Yes, we got 1.5 million. So I will go to the heat exchanger and replace it or repair it. So I click on heat exchanger and click repair this item. And we see in my net profit loss, it's already subtracted this cost. We are now have less than 1 million again. And the heat exchanger, the condition is at 100%. I think if you get too high reactor temperature, you will have eventually emergency venting, which will cost money because you need to pay fines if you release radioactivity to the environment. And you can also, it seems you can also damage this venting, emergency venting. Yeah, it seems you can also damage it. There must be some HEPA filter or something that needs to be replaced. 100 megawatt nuclear power plant simulator model H9000. It even has a serial number. And you see here how the days pass. We are at the day 32 and the hours are here. It's like 1 hour is 1 second. So this is accelerated 3,600 times. You even have here the cost per kilowatt hour, which is $0.12 US, it seems. A bit expensive. I think in Europe biddings, energy is about €0.05 per kilowatt hour. At the lowest, it's 0.01, and the record high can be 0.1. So this is even higher than the record high electricity price in Europe. I think it's not very realistic. But anyways, it's like here you're getting the price with the tax and everything. It's not really what the nuclear power plant operator gets. Okay, so we are approaching 2 million. I think I can increase a bit reactor power. And let's see what's the cost of the fuel rod it's 1 million. To replace the fuel rod is 1 million, and if you replace the reactor core, it's included. So in case you had some damage in the reactor core and you are about to replace the reactor core, do not refuel before, because you get a free refueling with a new core, which is not very realistic. In real life, you don't replace nuclear power plant cores. If the nuclear core is damaged, it's the end of the nuclear power plant. Okay, everything is going smoothly. So now we have 2 million, and I think I already show like all the basics of the simulator. It's good that now you continue by yourself, but assuming that you continue for some minutes or hours and the day number gets to 1 year or 1 year and a half, you may need to replace the fuel rods. When you do this, you increase a lot reactivity because you are inputting new fresh fuel without poison products, which is much more reactive. It means you cannot just replace it and leave everything as it is. It will go very quickly to the maximum temperature and you will blow up the reactor. You need to decrease the reactor core notch, which is inserting control rods. I will do it just for showing you. So if I click fuel rod live and I repair now, I will blow up things. So what I need to do is to decrease a lot reactor core power. Let's say to 20%. Now I click fuel rod live and click repair this item. I spent 1 million on doing so. And now I can go back to increase the power so it doesn't stall the reactor. It seems to be stabilizing below 700 degrees. Let's go back because it's too hot. Yes. Let's increase secondary coolant because the turbine is at a very low set point. Let's increase just one tiny bit the primary coolant and increase the secondary. I didn't pay attention, but I think when I refueled, it automatically decreased the secondary coolant. Otherwise, I don't know why the AC generator went too low. I didn't touch at all the secondary coolant. Okay, let's increase a bit primary and a bit more secondary. A bit more reactor power. And a bit more secondary. I'm a bit critical in the primary coolant pump. It's almost 2 degrees below the critical level. And you see it's decreasing in secondary. What's happening? Secondary flow cannot exceed 65% of heat exchanger temperature. Cannot exceed 65% of... What does it mean? How to compare flow with temperature? Secondary flow cannot exceed 65% of heat exchanger temperature. I don't really understand this statement here. Increase heat exchanger temperature or reduce secondary coolant flow. Secondary coolant pump. I don't understand this. What it makes no sense. I guess I'm missing the point. It means something else. Okay, let's increase a bit more reactor temperature, decrease a bit coolant, primary coolant because we're almost at the limit, and increase a bit secondary. Yes, that's perfect. Maybe in the reactor we will overshot the temperature now, 720. No, it just stabilized. So now we are at the maximum. We're almost producing the 100 megawatts design. Let's try to do it by increasing secondary coolant. Yes, we're at 100 megawatts. Let's see if the last top of the high-rise building lights up. I would like to see it. Yes, we are lighting up all the city. So we are at the peak production now and peak consumption. And now is when we will make more money, when we are at peak production. Okay, I hope you enjoyed this tutorial of a very simple 3-notch simulator. I have another 3-notch simulator. Maybe I will make another video about it. If you have any questions, put down in the comments. Thanks for watching. Bye.